This is my database normalization task. So for the problem number 1, in problem number 1, we start with a table that holds information about appointments with attributes such as staff number, the dentist name, the patient number, the patient name, the appointment date and time, the surgery number. So to meet the criteria of the first normal form, or the 1NF, we need to make sure that each attribute contains only atomic values, meaning that there should be no multiple values in a single cell. Looking at our table, we find that each attribute holds a single indivisible value, so it already satisfies the first normal form. However, the table still has repeating data which we want to minimize to avoid the redundancy, which we will do in the second normal form. So for the second normal form, the next step is to move to the second normal form, or the 2NF, which means eliminating any partial dependencies. So in this case, we have fields that depend only on parts of the composite primary key. For example, the dentist name depends only on the staff number as a primary key, while patient name is depends only on the patient number. So we will create the new tables, which is the patient table, the dentist table, and the appointment table. So the dentist table is containing the columns, the staff number, and as the primary key and the dentist name. So the dentist name is depending on the staff number. So for the patient table, it contains the patient number and the patient name. That the patient name is dependent on the patient number. So for the appointment table, it links to the dentist and patients with the attributes the staff number, the patient number, the appointment date and time, and the surgery number. These are all the primary key. This separation removes the partial dependencies, ensuring that each non-key attribute fully depends on the entire primary key. So for our third normal form, or the 3NF, we need to remove any transitive dependencies. A transitive dependency occurs when a non-key attribute depends on another non-key attribute, rather than directly on the primary key. Since each table in the second normal form is no longer has any transitive dependencies, we have fully normalized this structure to the third normal form. So, for the for the problem number 2, so, an agency called Instant Cover supplies part-time or temporary staff to hotels throughout Scotland. The table shown in Figure 2 lists the time spent by agency staff working at the hotels. The National Insurance Number, or the NIN, is unique for employee. So, for the problem number 2, for our first normal form, looking at the table, we can see it already meets first normal form, or the 1NF, since all values are atomic also and there are no multi-valued attributes. Each cell contains only one single value, such as unique contract number or the employee's name. So, for the second normal form, to reach it, we need to eliminate again the partial dependencies. Since the primary key is a combination of the NIN and the contract number, each non-key attribute should depend on the entire composite key. However, we see that some attributes like the e-name and the hotel location depend on only part of the key, so we break the table into three separate tables. An employee table which contains the NIN and the e-name, a hotel table which contains the hotel number and the hotel location, and the contract table which contains the NIN and the contract number, the hours per week, and the hotel number. This ensures that each attribute now depends fully on the primary key of each table, eliminating the partial dependencies. So, for the third normal form, in the third normal form, we will ensure that there are no transitive dependencies. Transitive dependencies are dependencies between non-key attributes where an attribute depends on another key non-key attribute rather than the primary key. Since we have organized the data so that each attribute depends only on the primary key, this structure now satisfies the third normal form, completing the normalization process for the problem number 2. So, moving on to the problem number 3. In problem number 3, we have a table that tracks the student and the courses they are taking, including fields like the student ID, the course ID, the faculty phone number, and the grades. This table holds a lot of information, but it also has a lot of repetition that could lead to anomalies if we need to update or delete the records. For the first normal form, To start it, we need to ensure that each field contains only atomic values. Since each cell in the table, this is the table, holds just one value, the table already satisfies the first normal form. However, there are repeating groups of information, especially with the faculty data, that is repeated in the multiple rows. So we still have some redundancy to address. So for the second normal form, we will need to remove the partial dependencies which occur when non-key attributes depend only on part of the composite key. So here, the student name depends only on to the student ID, while the faculty phone depend only on the faculty member. To eliminate these partial dependencies, we will create the student table, the faculty table, and the course table. So the student table has the columns the student ID, which and student name. The student name is depending on the student ID. So for the faculty table, it contains a faculty name and the faculty phone number. For the course table, it contains a course ID, the course name, the faculty and the grade, and the student ID. This separation helps reduce redundancy by ensuring each attribute fully depends on the primary key. So for the third normal form, in the third normal form, we need to ensure that no non-key attributes are dependent on other non-key attributes. After splitting the tables in the second normal form, this is the second normal form, we find that no transitive dependencies as every non-key attribute directly depends on the primary key of its table. Therefore, this structure is now in third normal form, completing the normalization process for the problem number 3. So for the next problem, which is the problem number 4, this is the problem number 4. So the problem number 4 contains a table with order information, including attributes for the order date, the customer details, the product information or the description, and the quantity ordered. The initial table has a lot of data, but it's prone to redundancy and anomalies if you don't organize it better. So for the first normal form, so our table meets the first normal form since each attribute has atomic values, but as it is, it's still inefficient due to the redundant data. We still need to split it up to prepare for the second normal form. So this is our first normal form table. So for the second normal form, in the second normal form, we will focus on eliminating the partial dependencies. Here, the customer ID and the customer state depends only on the order ID, and the product description and the product price depend only on the product ID. We can split the table into the orders table, which contains the order ID, the order date, and the customer ID. So second one is the customer table, which contains the customer ID, the customer name, and the customer state. For the third table, it contains the order details, which contains the order ID, the product ID, and the quantity. So for the fourth table, and lastly, the fourth table contains the product ID, the product description, and the product price. This restructuring removes any partial dependencies, ensuring that each attribute fully depends on its table primary key. So for the third normal form, finally, we eliminate transitive dependencies in third normal form. Each non-key attribute now depends only on the primary key of its table, meaning that the structure meets the third normal form. We have now completed normalization for the problem number 4. So it's also the same, the third normal form is also the same to the second normal form. So for the last problem, which is the problem number 5, this is the problem number 5. So in problem number 5, we are managing employee assignments to project with different departments, with fields for department ID, the employee ID, the project ID, and the billing time. Let's walk through each normalization step. So, for the first normal form, the table meets first normal form already since each field is atomic and contains a single value. So, we will move on to the second normal form. So, for the second normal form, we need to remove again the partial dependencies by breaking out the data that depends only on the part of the composite key, which is the composite key are the department ID, the employee ID, and the project ID. So here's the breakdown. So the departments table contains the department ID and the department name. So the department name is dependent only on the department ID. So for the second table, it contains the employees table. So it contains the employee ID and the employee name. So the employee name is dependent only on the employee ID. So for the third table, it contains the project table. So it contains the project ID, the project name, that the project name is dependent only on the project ID. So for the assignments table, it contains the department ID, the employee ID, the project ID, and the billing time. Each table now has non-key attributes that fully depend on the primary key. So for the third normal form, we will verify that each non-key attribute depends on only on the primary key of its table, with no transitive dependencies. Since each table in the second normal form meets this requirement, the structure in the third normal form, the structure is already in the third normal form. So the problem 5 normalization is now complete. So in each problem we went through the process of normalization from first normal form to third normal form. This systematic approach helps ensure data is organized efficiently, minimizing the redundancy and preventing update anomalies. By splitting the tables and creating relationships based on dependencies, we are left with a robust database structure that's easier to maintain. So thank you for listening.